Okay fellas, I'm glad to see you're still awake. Now we're continuing to exact trigonometric ratios, and I want to focus on something called the unit circle. Now it's called the unit circle because it's a regular old circle with a radius of 1 unit. Okay, so we could say r equals 1, r for radius, and of course that's a radius 2, that's 1, and that's a distance of 1 as well. Okay, so that's that's why it's called the unit circle. It's a circle with radius 1. Lots I can say about this. Where to begin? Well, I suppose the first place is to realise that if I've got a random angle, let's call it theta, and I've got a right angled triangle like so, there's the right angle there, what can you tell me about the sine ratio? Well, what you can tell me probably is this, that it is the opposite side, OP for opposite, that's that there, over the hypotenuse, isn't it? The hypotenuse. Now, the thing about the hypotenuse is that it has a radius 1. So really, the sine of that angle, sine theta, opposite over 1, well, it's just the opposite side. Now, here's something else. We can put in, we can label our axes as follows, x and y in the usual way. What do you notice about the opposite side in relation to x or y? Well, what you should notice is that it's going to have the same length there as the corresponding y coordinate, isn't it? So in summary, we tend to associate the sine ratio, so sine theta, with the y coordinate. Okay? Now what about the cosine ratio? Well, the cosine ratio we know is adjacent over hypotenuse, isn't it? So adjacent over that handy hypotenuse, and it's handy because we've set it to equal 1. And what do you notice about the adjacent side there? Well, it's the same as the x coordinate, isn't it? So we associate the cosine ratio with the x coordinate. And here's something else. We associate the tan ratio with y over x. Now, why is that the case? Well, it's the case for a couple of reasons. I could demonstrate it a couple of ways. But remember that the tan ratio is simply the opposite over adjacent side. But we've already associated the opposite with the sine ratio up here, and we've associated the adjacent with the cosine ratio there, the x-coordinate, and so the tan theta is simply y over x. So to continue with our unit circle, to follow on from question 7, which you've just done, you would have noticed there were questions there about sine 90 and cos 0 and all this sort of thing. Let's have a look at the unit circle and see how we interpret that. Well, if we go to 90 degrees here, map out 90 degrees from 0, we always start from there. What can you tell me about the y-coordinate, the value of the y-coordinate? Well, it's the unit circle, remember, so the distance from there to there is 1, so the y-coordinate will be 1. So the y-coordinate, now it's the y-coordinate we associate with the sine ratio, remember? So sine 90 equals 1. And what do you notice about the x-coordinate at this point? Well, the x-coordinate is, of course, 0. So what we say there is that cos 90 degrees is equal to 0. Okay? And what about the tangent? Remember I said tan 90 was undefined? Well, why is that? Well, it's because the tan ratio, remember, so tan theta equals sine theta, or the y-coordinate, over cos theta, or the x-coordinate. And that, of course, is going to equal 1 over 0, which is undefined, or infinity. Okay, so that's the connection with before. Now, what about some of the others on the boundary? What about sine 180, for instance? Sine 180 degrees. Well, can you see that it's going to equal -1? that it's going to equal 0. Okay, so sine 180, go from there to there. You're asking yourself, sine y coordinate, well the value of y at this point is 0, isn't it? And what about cos 180? That's going to be -1, isn't it? Because the cosine we associate with the x coordinate. Well, the x coordinate out here is -1. Okay, and so we can use the unit circle to evaluate the sine and cosine ratios at the boundaries, what we call the boundaries, 90, 180, 270 and 0, or 360 degrees. 0 and 360 degrees are equal. Now let's extend these ideas a bit further. If we associate the sine ratio with the y coordinate, we can see that the y coordinates are all positive above the x-axis, can't we? So what does that mean? Well, it means that, for example, the sine ratio is going to be positive in the first quadrant, number 1, and the second quadrant as well. I'm just going to put an S there, okay? What about the cosine ratio? Well, the cosine ratio, remember, cos 180 we discovered was -1. So the x's are all negative this side of the y-axis, aren't they? So the cosine is going to be negative there, and it's going to be negative there. But it's going to be positive over here, isn't it? As well as here. All the x-coordinates are all positive over here. So the cosine ratio will be positive in the first and fourth quadrants. So let me just put a C there. And what about the tan ratio? Well, the tan ratio, remember, is really y over x, or sine theta over cos theta. And it's going to be negative in the second quadrant, isn't it? Because you've got a positive divided by a negative. It's also going to be negative here because you've got a y coordinate, which is negative, the y's are negative here, divided by an x coordinate, they're positive. Negative divided by positive is a negative. But over here, where your x's and your y's are both negative, the tan ratio is going to be positive. So we can put a T there. And in the first quadrant, everything's positive, isn't it? Because your x and your y coordinates are all positive. Okay, now that's going to help you address questions on page 217. Page 217. Okay, I think it would be a good idea if you just copy down this diagram. So if someone would be so kind as to press pause, I think it would be a good idea to have a copy of the unit circle before you proceed. Okay. Now let's have a go at some of the questions that you'll find on page 217. Questions 1 to 3, they're pretty similar. One's about the sine ratio, two's about the cosine ratio, and 3 the tan ratio. They're all fairly similar. There's a couple of interesting ones in there, but I'll take you through a couple examples like in questions 1 to 3, but you won't find them in 1 to 3. Okay, so firstly, my first question is going to be, just tell me whether sine, for example, 210 is positive or negative. Well, we start here. We always start here. And 210 is just a bit past 180. It's certainly before we get to 270, isn't it? And we can see that the only ratio that's positive in that quadrant, which is the third quadrant, is the tan ratio. So that's negative. So you'd write an N there. Okay, let's try another example. What about tan, I'm trying to catch you out here, negative 54. Okay, negative 54. Well, negative 54, we would start there and go 54 degrees that away. And it's when you consider that it's 90 degrees from there to there, 54 is only going to be from there to about there. Okay, so it's tan negative 54 degrees. We can see that only the cosine ratio is positive in this quadrant, so the tan of negative 54 degrees would be negative. And a third example. Let's have a look at cosine 540. Where's 540 degrees? Well, you probably know this. how this works. But you know that 360 is a full circle, and if we keep going around another 180 degrees, we will get to 540, won't we? So 360 plus 180 is 540. So in fact, the cosine of 540 is on the 180 degree line. You get that? So 0 to 360, keep going another 180 degrees to get to 540, lands us on this line here. And we've already discovered that the cosine of 180 would be negative, so the cosine of 540 would also be negative. Okay, now you can have a go at those questions 1 to 3. Finally, you can have a go at question 6 on page 207.